Okay, so find the appropriate critical value for constructing a confidence interval in each of the following settings. So the first one, we're estimating the population proportion P at a 94% confidence level based on a simple random sample of size 125. So for this, we're going to need to find the Z-star value. So if we're talking about 94% confidence level, we can just draw a sketch of what this can look like. And looking at a normal curve, we're basically looking at a normal curve where there's 0.94 area in the middle. So the 0.94 is bounded by the negative Z-star and Z-star values. That means there's 6 total percent left over, or 0.03 on each side. So then we can just use our calculator to figure out the area with an inverse norm function. So we're going to press vars, but then we're going to want to go to distribution. So second vars, go down to inverse norm, and we type in the area to the left. So 0.03. And that'll give us negative 1.88. So that'll be our negative Z-star value, which means our positive Z-star value is 1.88. And that's our answer for that. Now, part B, we're going to estimate population mean at a 99% confidence level based on a simple random sample of size 58. So same sort of thing, except we're actually looking for the T-star value. So we're actually looking at a T distribution, 0.99 in the middle. So that'll be our negative T-star, and this will be our positive T-star. And that means there's 1% left over, or 0.5% on each side. Now, the other thing we have to take into consideration is our sample size, because we have to figure out our degrees of freedom. And that's because every T distribution has a unique shape based on its degrees of freedom, and degrees of freedom will be one less than our sample size. So the sample size is 58, and so our degrees of freedom will be 57. Now, some calculators have this as a function where we can just figure it out using an inverse T function, but this one doesn't, so we'll just use a table. And in this table, we look for the degrees of freedom, and since this value 57 is not on here, we're going to use the one closest below. Even though 60 is closer to 57, we have to be conservative, so we're going to go with 50. So then we go to 50 and we look at the column that matches the 99% confidence interval. So we look at this column, we shoot across, and we'll have our T-star value at 2.678. There you go. All right, problem 2. A company that produces AA batteries tests the lifetime of a random sample of 30 batteries using a special device designed to imitate real-world use. Based on the testing, the company makes the following statement. Our AA batteries last an average of 430 to 470 minutes, and our confidence in that interval is 95%. So part A, we're going to determine the point estimate, margin of error, standard error, and the sample standard deviation. So let's just break this down. And let's show like the visual of what like the confidence interval is constructed from. So we start our point estimate in the middle of our confidence interval. And the endpoints are, the lower and upper values. So that's 430 and 470. And since we're talking about means, our point estimate is going to be a sample mean. In the middle of 430 and 470 is 450. So our point estimate is 450. That's our point estimate. Now, let's look at how we figure out margin of error, standard error, and sample standard deviation by looking at the formula for the confidence interval for sample mean. And the way that works is that our confidence interval will be x bar plus or minus t star times the sample standard deviation over the square root of our sample size. Now, the way this works is that X bars are point estimates. We got that. T stars are critical value. We got that. Now, this whole quantity, T star times this, is our margin of error. And S sub X, that's just our standard deviation, or it's our sample standard deviation. Sample standard deviation. Now, this whole quantity in the pink, that's our standard error. So we have to figure out what those three values are from here. So the margin of error is just the distance from the middle or point estimate to the ends of our confidence interval. So it's basically the distance from here to here. That'll be the margin of error. It's the same both ways. So the distance from 430 to 450 is just 20. So our margin of error is 20. And so if we're going to rewrite this, we can basically set this up as X bar, which is 450 plus and minus 20. So to find our standard deviation of our sample, we can just basically set this entire quantity up to 20 and solve from there. And from that same thing, we can also find our standard error. So let's just go ahead and do that. So we're going to set 20. 20 will be equal to T star times S sub X over the square root of N. Our T star, we look at the critical value for a 95% confidence interval. And we need to look at the degrees of freedom, and that'll be 29, one less than N. So we look at degrees of freedom 29 for our 95% confidence interval. So we go across to 95, and that'll be 2.045. Now that's our sample standard deviation. Square root of N, I'll be just square root of 30. So remember, this is our standard error, so we can just divide both sides by 2.045, and that'll give us our standard error. So 2.045 being divided by both sides. And we'll get our standard error of about 9.78. Now all that's left is to find the sample standard deviation. And all we have to do is, since we have that our standard error is, is this thing, we can just solve for the sample standard deviation by using algebra. So essentially we have this. We have 9.78 is equal to our sample standard S sub X divided by the square root of 30. So we just multiply both sides by the square root of 30. So 9.78 times the square root of 30, and we'll get about 53.57. All right, there we go. All right, problem 3. A recent Gallup poll conducted telephone interviews with a random sample of adults aged 18 and older. Data were obtained for 1,000 people. Of these, 37% said that football is their favorite sport to watch on TV. Part A, so define the parameter P in this setting. Explain to someone who knows nothing about stats why we can't just say that 37% of all adults who say that football is their favorite sport to watch on television. Okay, so we can't say that 37% of all adults would say that football is their favorite sport to watch on TV because this 37% is just a sample proportion. This 37% comes from a sample. Now, it's possible that the true proportion of the population is 37%, but maybe it's not. So this is only referring to the sample. So we can't say that they refer to all adults. Check the conditions for constructing a confidence interval for P. So the conditions that we need to check are the random condition, the 10%, and then the large counts. Random condition, just check to see if there's a random sample that was done. A randomized experiment, and it says that there was a random sample conducted. So like that is met. 10%. So basically we want to say that this is nowhere 10% of our population. So basically our population has to be at least 10 times 1,000, so at least 10,000. And that makes sense. There's at least 10,000 adults, in the population. And then the large counts is that n times p hat and is at least 10, and that n times 1 minus p hat is at least 10. Now, this is also just known as the number of successes and failures. So what that means is that, so n times p hat will be 37% or 0.37 times 1,000. So this will be 370. And that's more than 10, so that's good there. And if there's 370 here, that means there's going to be 730 left over because 730 plus 370 adds up to 1,000. So both those are at least 10, so that condition is met. Part C, construct a 95% confidence interval. So we're going to use our formula that p hat plus or minus z star times the square root of p hat times 1 minus p hat over the square root of n. Our p hat is 0.37. That's just because 0.37 is the same as 37%, so it just tells us that straight up. Z star, we look at the Z star value for a 95% confidence interval. So basically we're looking for the interval where there's 2.5% on each side. 5% left over and 2.5% on each side. So we go to we can use our inverse norm function, 0.025 and 1.96. And that's a pretty common one, so you probably will just like remember that, just doing it so much. Now we do p hat times 1 minus p hat under the square root. So p hat, that'll be 0.37. 1 minus 0.37, so that'll be 0.63 over 1,000. And we just gotta be careful to not mess up any on our algebra. So we're gonna have 0.37 plus minus. So let's do this all like carefully in our calculator. So I would work from the inside out. So I would go 0.37 times 0.63, 0.2331 is on top. Divide that by 1,000. I'm gonna get this. This is the same as 0.00023. This is just scientific notation, so it just means that 2 gets moved over 4 spots to the right. But you don't even have to worry, because if you just know to take the square root of this, which is the same as raising this to the 0.5, that'll take care of that. And then we multiply this by the 1.96 times 1.96. 0.0299. And again, rounding is not too big of a deal if you get roughly close. So we're going to add and subtract that to 0.37. So plus 0.37, all right, that'll be our upper bound, and 0.37 minus 0.2 or 0.0299. I'll give us our lower bound. So 0.3401 to 0.3999. So that's our confidence interval. And to interpret this in context, we just say that we are 95% confident that the interval 0.3401 to 0.399 contains our true population proportion, which is representing the true proportion of adults that say that football is their favorite sport to watch on television.